in solutions. For example, if substance conduct electricity, if solutions can conduct current through solutions to any device, we name these compounds electrolyte. If solution of compound not conduct electricity, we name this compound not electrolyte. So just one property, conduct or not conduct electricity, nothing more. And sometimes if we describe conductivity of electrolyte and not electrolyte, sometimes we group in electrolyte into two groups. Strong electrolyte, which conduct electricity well, and weak electrolyte, which conduct not very well. And whole strong, weak electrolyte we can also grouping. For example, if we look on electrolyte only, we can find, so strong electrolyte, it's sometimes acids, base, and salt, and weak electrolyte, it's acid, base, and salt. And if we look on strong electrolyte, typically it's mineral acid. For example, my favorite acid is sulfuric acid, H2SO4. If we're talking about base, it's compound with OH groups, first or second group, KOH, for example, potassium hydroxide, and salt, for example, NaCl, kitchen salt. It's all compounds, strong electrolyte. Weak electrolyte, it also can be acids. For example, CH3COOH. It's acetic acid. We will discuss a lot about this compound in future. It's also acid or mineral acids such as HF, hydrochloric acid. Base is most famous ammonia. Ammonia, it's also weak base. And weak electrolyte, it's some salt, AgCl, for example. Insoluble salt, weak electrolyte. Soluble salt, strong electrolyte. With acid and base, it's more complicated, but if we generalize, most acid, it's weak acid. So if we interested about strong, it's HCl, H2SO4, nitric acid, some mineral acid, most famous. If you see any acid it's when hydrogen in first place, it's more probable it's weak acid, because most acid are weak and only strong acid you must memorize. Same principle with base, but with base it's more simple. Potassium, one moment, potassium, sodium, calcium. So all elements in first and second group except beryllium and manganese, they form soluble strong base. And if we're talking about salt, absolutely all salt of sodium, potassium, salt which contain nitrite group, all this salt always soluble. And weak base, it's absolutely opposite. Any salt, any acid, and any base what not in first group, it's weak. For example, benzoic acid. even formula not right here. Or for example, H2CO3. It's quite weak acid, and it's not from group. For example, zinc hydroxide. It's not from first and second group, so it's weak. And calcium carbonate, a very popular non-soluble salt. It's also not electrolyte. And scientists find some principle in all electrolyte reaction, because we have three groups of compounds, acid, base, and salt. In some case, some substance, some acid, some base, and salt react, and some acid, some base, and some salt not react. And here we have 5 types of reaction. First type, it's acid react with base. It's most simple one, most common one. For example, HCl react with sodium hydroxide. It's most popular acid-base reaction in the world, and in this case we form salt, NaCl, plus water, H2O. And you probably solve a lot of questions about titration, or more complicated case, for example, H2SO4, it's sulfuric acid with zinc hydroxide, for example. We form also salt, zinc sulfate, and water molecules. Difference only coefficient. So acid react with base and form salt and water. Second type, active metal react with acid and form salt and water. For example, HCl react with zinc, form salt, zinc, Cl2 plus hydrogen. It's historically first way how to scientists produce in lab hydrogen. Or for example, H2SO4 plus iron, forming iron sulfate and hydrogen. And here no needs to coefficient. Third type of reaction, it's active salt react with salt of not active metal, react with active metal. For example, how I cover by by silver Belarusian coin. When I buy in bank silver and synthesize silver nitrate, then I put Belarusian coin in silver nitrate solutions, AgNO3. My coins covered by silver. So I make my own Belarusian silver coins. Or for example, if we have iron chloride and put inside piece of zinc, this reaction is why any steel or iron metallic surface were often covered by zinc. Even if iron oxidizes, very soon this iron will be reduced again and zinc will be oxidized. And number 4 type of reaction, it's strong acid react with salt of weak acid. and strong base react with salt of weak base. For example, first type, if you drink a lot of sodium carbonate, for example, NaHCO3, its main component, some of mineral water, and in your stomach present hydrochloric acid. So sometimes if concentration of hydrochloric acid in your stomach high, you drink mineral water, like, for example, like this. Here a lot of hydrocarbonates. In most mineral water involved a lot of hydrocarbonates. And in this case, we produce weak, very weak AH2, or we produce very weak H2CO3 acid. Which immediately split into carbon dioxide and water and NaCl. So if concentration of hydrochloric acid in your stomach high, you can drink any hydrocarbonates and your acid will be neutralized. Same principle, something strong replace something weak with bases. For example, in ancient Egypt, old chemists find source of ammonia, and if you mix it with, for example, any base, sodium hydroxide, you produce NaCl and ammonia hydroxide, which like H2CO3 split into water and ammonia. So strong acid react with salt of weak acid. Strong base react with salt of weak base. And final type of reaction is when soluble salt react with soluble salt and form insoluble salt. For example, in analytic chemistry, most popular ionic reaction, it's way of detection chloride ions. Chloride ions must present in tap water, for example, but in injection water must be free from any ions, even if it's safe. For example, NaCl, it's aqueous. This compound soluble in water react with silver nitrate. At the present chloride, these two substances react and form silver nitrate, sodium nitrate, and silver chloride. Solid plus NaCl plus NaNO3. So soluble salt can react with soluble salt if you can form insoluble salt. If you have this possibility, reaction will happen. Another one reaction, for example, if we have calcium chloride, this substance in European country very often used as roads treatment. If you add sodium carbonates, reaction will also happen because you can form sodium chloride and calcium carbonate. Yeah, it's final one. So if we generalize, we have 5 types of reaction. Acid react with base. It's almost ever. Acid react with metal, active metal, forming salt and hydrogen. Salt react with metal, and forming new salt and new metal, in case if inside salt metal less active. And strong acid or base replace weak acid or base. And last one, if you can form from something soluble something insoluble, reaction will happen. So all tendency for all this reaction, if we have something weak, if you have something strong and can form something weak, reaction will happen. For example, water is weak electrolyte, hydrogen is weak electrolyte, new metal it's also weak electrolyte, weak acid it's weak electrolyte, insoluble salt it's weak electrolyte. Acids, it's even if you're dealing with weak acid, it's typically more strong than water. So more strong water can form more strong electrolyte water, more strong electrolyte acid can form more weak electrolyte water. Same principle with this case, and same case with number 3, because more strong metal replace weak metal. Strong acid, it's definitely strong, can replace weak. Soluble, it's also strong, replace weak. So overall, general tendency for all electrolyte reaction, from strong you get weak. From acids, from strong acid, weak acid. From strong base, weak base. From soluble salt, insoluble salt. From active metal, not active metal. So all tendency for all electrolyte, not electrolyte reaction, it's from strong you get weak. A general principle. So as I say before, all substance, behavior of all substance in solutions, it's causing classification. All substance solutions we can group in by 2 groups, electrolyte and not electrolyte. Electrolyte conduct electricity in solution, non-electrolyte not conduct electricity in solution. Some electrolyte strong and conduct electricity well. Some electrolyte we name weak and they conduct not very well. Strong electrolyte, it's a small group of mineral acids. Strong base, it's groups, it's first, second group of elements from periodic table, and some salts. Most acids, most base are weak. So you just memorize strong and all rest weak. So acid react with base, acid react with some metal, salt react with some metal, strong acid and base react with weak acid and base, and soluble salt can react with soluble salt if you can form insoluble salt. So I think for today it's all, and next time I will continue Friday, same time, and next topic will be when and why acid and base react, electrolyte 2. I will teach you how to write ionic equation and net ionic equation, and I show similarity in ionic equation for all 5 types of reaction. Thank you for visit my lesson. See you soon. See you on Friday.